Hello and welcome. As I make this video, I am also in the background struggling to get my computer back up and running. I've got 3 videos in the queue and I have not been able to post any of them because I can't get my editing software to work. After my computer went down last month, I tried to shift all my files over to the new one with all my videos and all the history. And now every time I try to run the video editing software, my computer locks up, and I've deleted the program twice and reinstalled it, and every time I open the program it locks the computer up. This is just frustrating beyond belief. Right now I'm doing a system restore to an earlier date, and I'm hoping this clears the problem up. But I'm making this video in the hopes that I can get this straightened out. It has been a very agonizing couple of months between work and everything else that's been going on. At any rate, in a previous video I showed you this Cushman service monitor that I had picked up at the flea market this last weekend, October 13, 2017. And it came to me as not working. It was given, the guy gave it to me along with the plug-in units and said it just doesn't work. He said it did not smoke, but when he turns it on, the only thing that lights up is the digital digits in the front, and one of those is out. And since he had recently plugged it in, I went ahead and plugged it in and turned it on. And sure enough, the unit was completely dead, other than the lights lighting up behind the digits. Now the digits are merely dials with pilot lamps behind them. And the one that's out merely has a burned out pilot lamp. So that showed that at least some of the power supply was working. The main fuse was good. But everything else was dead. There was no response from the meters. There was absolutely no output from anything. Little quick investigation, and I found a 1.5 amp fuse right here blown in the power supply. And there's like a 20 volt and a 15 volt and a 40 volt power supply. And this one was blown. It was a slow blow fuse. I measured across its associated capacitor and there was no short anywhere apparent in the system. It was very high resistance. So I went ahead and put a fast blow 1.5 amp fuse in. Turned the unit on and immediately had smoke coming out of the back side of the CRT unit here, the oscilloscope unit. And I'll show you what I found. The scope unit out. And that resistor right there was smoked. And in fact, that's still the original resistor in there. I haven't replaced it yet. It didn't burn through completely. It just burned most of the covering off the resistor, but the resistor is still intact. Turned out that this capacitor, the one that's replaced right here, was a dead short. And it was obvious it was going to be that capacitor when I looked at the schematic. Pulling up the schematic for that board with the burned out resistor. It says here 12 volts from plug number 1, pin 13, test point 11, and that's right where that resistor is mounted. It says R7 100 ohms. You've got C3, a 100 microfarad capacitor, and then the circuit runs off through various transistors and resistors, and it instantly became obvious that nothing over here could be the problem that was causing the resistor to go up in smoke, because we have all high value resistors, 22K, 18K, 30K, 60K. There's no path to ground that doesn't go through a fairly high resistance. So none of these transistors could be the problem. It was obviously clear that the only thing that could be giving me a dead short to ground was this capacitor. And sure enough, that was an absolute dead short. And it's a Sprague. That really surprised me, even though it's an older Sprague, 100 microfarad at 25 volts. It was an absolute dead short. Another curious thing is this says R7 is 100 ohms, and the resistor that's in there, even after being well baked, which usually brings their value up considerably, measures 20 ohms. So I think I'm going to throw a 50 ohm resistor in there and split the difference. This might have been an update at some point, or mine might be the update. I have no idea what the age of this is versus this schematic. Another thing that threw me is, just as a sanity check before I plugged the scope unit back in, I went back and I checked the voltage at pin 13 of plug number 1, which led to this point. This was reading about 20 volts. And it says here very clearly, plus 12 volts. But it was reading 20. And I said, I've got a regulator pass transistor shorted somewhere. Well, I spent the next 2 hours going through all the schematics, and these are all PDF on a CD-ROM, or a CD that somebody gave me. Actually, the guy who gave me the unit gave me. And I hate working from a computer screen with scanned-in schematics. It just drives me nuts because it's so much harder and it takes so much longer to scan through and find what you're looking for. At any rate, after about 2.5 hours of searching, I couldn't even find a plus 12 volt supply associated with this unit. And I was really starting to get kind of cranked up. Tracked the wire back, found the pass transistor, and the pass transistor was fine. It led back to the 40 volt supply back here, but it was reading 20 volts. And I'm like, how can that be? And I was just sitting here staring at this schematic for a while, and then I spotted this. This says 18.1 volts at this test point, internal on the horizontal amplifier. Well, you follow that back, that goes right through this 100 ohm resistor and out. The voltage is coming in and they're expecting 18.1 volts here. You're not going to get 18.1 volts from 12 volts. Oh, by the way, I forgot to mention, there's no 12 volt plus 12 volt supply in this unit according to the schematics, period. There's a minus 12 volt supply, and no, they're not deriving 12 volts from it. This comes directly from a different source, and it's supposed to be at 21 or 20 volts. I think somebody transposed the 1 and the 2. This is supposed to be 21 volts, P1 from 13. It's the only possible way on earth you're going to end up with 18.1 volts over here. So that's a mistake that cost me, on their print, that cost me 2 hours of searching, trying to find, by going page after page through the PDF back and forth on my computer screen, trying to find the 12 volt supply that didn't exist in the unit. That was frustrating. At any rate, I went ahead, replaced the capacitor, put the unit in the machine, and turned it on. And guess what? It works. Okay, I've got the instrument set for 146 580 megahertz in the 2 meter band, because I have a 2 meter insert pre-selector. Up over here, this guy right here is my Hewlett-Packard signal generator that is tied to a GPS disciplined oscillator. That thing is dead on the money. So there's 146 585 megahertz. And if we come back down here, you can hear it being decoded. If I turn this up, I've set the signal generator for 3 kilohertz of deviation. Now when I say this works, it still has a few quirks to work out, but it's working. It does function quite well. The synthesizer is dead on frequency, and according to this meter right here, this is frequency, this is how much you're deviating from the actual frequency, it's just about dead on zero. So that means my 146 585 of this synthesizer agrees with what my other signal generator is putting out within plus or minus, let's see, that's 1.5 kilohertz, so that'd be one, it says 500 hertz. So this is off at 500 hertz is what it says. That's really close enough for FM use. It's more than close enough. But just to prove that it does work, I am going to set the signal generator up here. I'm going to dial that in to 146 585. I'm going to offset it 5 kilohertz, and we'll see what happens. All right. My Hewlett-Packard generator is now at 146 585 kilohertz. And as you can see, we're on the 5 kilohertz scale, and we are exactly on 5 at the end of the scale. If I go to the 15 kilohertz scale, it falls right on the 5 here. So the frequency measurement is pretty much dead on the money. That's incredible considering this thing's probably been sitting around for years without being touched. The scope, you can see, if I wiggle knobs here, you can see the scope trace move around. There's still some dirty controls or something, some contact slightly intermittent that has to be dealt with. But I have 3 kilohertz of deviation, and if this was moved up, this is 2 lines, 3 kilohertz would be right here. We're on the 3 kilohertz on this scale. So we have 3 kilohertz of deviation showing on the scope. So I have 3 kilohertz of deviation on my oscillator, and this is showing a 3 kilohertz on the 15 kilohertz scale. Now we're on the 15 kilohertz scale. We have 3 kilohertz of deviation. Excuse me, I'm on the wrong scale. I'm looking at 5 kilohertz. This might be out. 1, 5. I was looking at the wrong switch. I'm still learning how to drive this thing, guys. You got to give me a break here. I haven't even read the manual to figure out exactly how to run the thing. So we still have some dirty switch contacts to deal with, and so on and so forth. And this thing really should be recapped. I don't think I'm going to be doing that. I'm going to be passing it on to someone else at some point. I'm not going to put $100 and something worth of capacitors in here. I already have a service monitor that does everything this does, plus lots more. But somebody with a repeater sight, 2-meter repeater sight, or if they even a 70 centimeter or 220 megahertz repeater sight, if you want to buy the other inserts, this goes up to 500 megahertz. This would make a great little tool after a little work to work on your repeaters. But I can't get it back now. There, it does come back occasionally. We've got a bad switch or something going on somewhere. Come on. At any rate, the scope's giving us a fairly accurate reading of deviation. The frequency readout, I gotta put this back on cal here. The frequency readout is pretty much on the money. 5 kilohertz, I did figure that out. You put this on calibration and you center it. Center the scale, and you go back to monitor and you get your accurate reading on deviation, or not deviation, how far you're deviated from the actual frequency. Not modulation deviation, but how far you've deviated from your set point. But again, the scope's working. The jitter, I think, is sweep rate. Yep, there it goes. There's some flaky connections in here, obviously. The whole scope unit should be recapped. The whole unit should be recapped. But the internal modulation's working. We're not transmitting right now. The internal modulation does work. The synthesizer works. Oh, here's something interesting. We have a 100 kilohertz output right here. And that is so close to being perfect, it's incredible. I've plugged into the 100 kilohertz local oscillator. And we take a look up here at the Hewlett-Packard frequency counter. Now bear in mind, for its internal reference, it's using my GPS disciplined oscillator. So that is within millihertz. You know, it's within 20 millihertz. There's 99.99998, and you can see it occasionally jumps over to 1. That's just noise that the system is picking up. That's pretty impressive. That has not been touched by me or anybody in years. So the local oscillator in this thing is pretty much dead on the money. You could take this thing out in the field as it sits today and verify your repeater operation. Pretty impressive for a piece of gear that was generated or manufactured back in the 70s. And again, probably hasn't seen any repair work in 20 or 30 years. The inside of this thing had such a layer of dirt in it, it looked like it had been left outside for a month in a sandstorm. But it's working just fine. Okay, we had one other thing we wanted to do with this. We're going to transmit with it. Oh, one other thing that this has got going on right now. Let me zoom back out here. And there we go. It doesn't hear anything until about 80 microvolts, and then it wakes up. I believe there's a setting in here somewhere for a squelch level, because when it hits that magic point at about 85 microvolts, it just pops open. It just wakes up. It isn't like the level slowly increases out of the background noise. There is no background noise until you hit that magic level. And I haven't even looked at the specs on this to see what it's supposed to have for sensitivity. In fact, let me take a look at that. Okay, according to the manual, the 305B plug-in, which is what this is supposed to have 20 microvolts of sensitivity. This one's not going active until about 80 microvolts sensitivity. And while it is possible the front end was damaged by somebody injecting too much signal into it, it sounds more like a squelch thing, where in other words, when the signal level comes to a certain level, it breaks the squelch and this thing just pops into life. It isn't like it's insensitive and noisy in the background. So I've taken the cover off of this. I pulled it out of the unit, popped the cover off, and sure enough, SQ, that must be a squelch control and an AGC level. Now, I don't have the service manual for this unit. All I have is the operator's manual with schematics, and it doesn't give you a lot of information. And in fact, it gives you no information on the plugins. They're probably out there somewhere, but the documentation I was given with this has no information on the plugins whatsoever. But I think it's safe enough to play with this pot, which I believe in my heart to be a squelch setting. I don't want to twiddle too many knobs in here because I don't have the service manual and I'm not about to buy it for this. At any rate, I'm going to try playing with what I believe is the squelch control. This also has a remote AGC, and without having a full manual, I wouldn't know how to apply that. But it looks like you can remotely control the AGC, or you can preset the AGC level internally. And again, I don't know where to go with this. There's, you know, the synthesizer's working correctly. The metering seems to be working correctly. There's some slight issues with switches and the scope, and it's a seeming lack of sensitivity. But we're going to see if we can fix that. And if we fix that, this thing's going to be like 95% done. Just before I slip the pre-selector plug-in back in, I have to admit that I was a little bit concerned when I opened this unit up for the first time, took the covers off of it. I found things like this board had been out at some point in its life. There's more solder joints down below that you can't see from this camera angle. And somebody with less than stellar soldering skills put this back in. There are also, this is not the correct screw. It's not even the correct length. It appears to be cross-threaded. The other screw that's supposed to be down in this corner is missing entirely. Fortunately, this is fairly securely grounded through these connections here and the three that are down below. And the board, while it can flex, is not horribly mechanically out of shape. But whoever took this apart, somebody played with this. And these are the wrong screws. There were also a couple of incorrect type screws on the scope plug-in unit. So somebody at some point's been in here playing. But they didn't do an awful lot of damage, and it appears that everything seems to be reasonably okay in here. Like I say, I was real concerned when I first opened it up, but my concerns are diminishing as more and more of this proves to be working in good shape. So we're going to slide the plug-in in, and we'll see if that squelch control has any effect. Well, that was interesting. I put the plug-in unit back in and set the selectivity to wide so I could retune the front end, and the unit didn't work. And after fiddling around for a couple of minutes, I flipped the switch to the sharp position, and I happened to know where on the dial supposedly the signal was, and it worked, but it wouldn't work in the wide position. So I took it apart and I sprayed the switch with some cleaner and flicked the switch a few times and put it back together, and it wouldn't work in either position. So we took it apart again and applied some more contact spray and vigorously switched the switch a few dozen times. And now it appears to be solidly working in the wide or sharp position. And the reason you need the wide position is, even in wide it's fairly sharp. Yeah, maybe the wide position's not working. Get off the signal here. Nope, I'm thinking the wide position's not working. It's only working in sharp now, no matter what position it's in. Oh well, so be it. I'm only going to go so far with this beast. Let's see. We're at 100 microvolts and we have a signal. So I'm going to drop the signal. Get around the other side of the camera here. Let me move the camera. Sorry about that. And you can hear what's going on. I'm going to turn the level down, amplitude down 90, 75, 66, 63 microvolts. It cuts off. Bang. And I'm going to come back up 66, 70, 75 microvolts. It comes back. So let's drop the signal level down to where we just lose it, 63 microvolts. And I'm going to try adjusting that, what I think is the squelch control. Now I've put a little flag on my stick here so I can get back to where I was if I have to. And let's see if we can get it to engage. Come on. Where the heck is it? It's that direction. Nope, it's not going on there. Why is it not dropping on the screw? There it goes. Okay, it's facing at me. 1, 2, 3. 1, 2, 3. I don't know which way to turn this. There it is. Bang. Now it's more sensitive. So it looks like we have to go clockwise. Let's turn the level down. 50, 47, 44, 39, 33, 29, 22. Now we're starting to get some noise. 14 microvolts and we still have a signal. So let's go back there. Actually, they said 20 microvolts was the sensitivity, and we're getting 14, so it's better than what they said. Let's go. Okay, as you can hear, there's a lot of noise in that signal now, a lot of scratchies. And we're at 11 microvolts, which is well below the published value or the published sensitivity for this unit. So I'm going to bring it back up to what gets quiet. There's 15 microvolts right there, so I'm going to set the squelch so it drops out below. Actually, there's a lot of hysteresis. Let's set it so it's gone at 11 and see if it comes back at 15. So there's 11 microvolts and it's noisy. And it cuts off. Now let's put 15 microvolts into it. Whoops. Yeah, 15 microvolts. Nope, it didn't recover. Let's try 17 microvolts. Nope. 20. Nope. A lot of hysteresis in this squelch. Still hasn't come back on. There it is. So 20 microvolts. Where is it going to cut off? It's not. Nobody wants to listen to that. Okay, we cut off. That's 5 microvolts. 6, 7, 8, 9, 10. Nope. There's 30 microvolts. So if we want to listen down there, we're not going to be able to set the squelch, evidently. That's 30. That's 20. 15. I think I'm just going to leave it open. That way you know there's some kind of signal happening. But I guess that could get mighty annoying. Let's see what we get here. 10, 12, 13, 15. Now, I'd sure like to see it open by 20 microvolts. And this may be an AGC setting for all I know. 15, 13, 11, 10. Nope, I'm not going to cut off. Might be why they have it set so high. Alright, I'm going to leave it so that, let's see where it does come on. Comes on about 35 microvolts. And for what this is designed to do, this is designed to be connected pretty much with a T or directly into the transmitter through an attenuation pad, something. It isn't designed to receive off the air as such, or if it's close enough to the transmitter it should. Let's see what happens. Oh! Yeah, the squelch isn't going to close. Alright, I'm going to set it so the squelch just closes. Let's turn on my HT and see what we get. We've got that. What did I do with the antenna for the... Oh, this will work. This will work. Let's see what happens when I key this up. Hello radio, 1, 2, 3. Hello radio, November 1 Charlie, kilowatt X-ray testing. Okay, so that's working. So that's an off-the-air signal. You just got to be fairly close to it. I think I'm going to leave it right there because that's actually what this thing was designed for. This wasn't designed to be a hypersensitive receiver. It was designed to work right into the repeater shack. So I think I'm going to call that working. We're going to put the covers back on this and call this done. Oh, I know what else I can do. Right here, we've got the transmit side. Let's see how it works transmitting a signal. Turn my HT back on, set its squelch. We'll set this for FM. And let's see here. Internal modulation, there we go. So, there you have it. Actually, let's turn this down. Turn the output down. We don't need all of that signal coming out of there. Wow. My HT is pretty sensitive. Alright. So that works. The signal generator portion works. It's on frequency because my HT is set on the same frequency. Oh, I'm lying to you. I'm lying to you. That's the internal speaker we're hearing. 146,850. Oh, makes sense. I'm not on memory anymore. There we go. Sorry. Trying to do too many things at the same time here. So, that works. The internal signal generator. I'm a little bit of a rush, guys. I'm trying to get this done so I can get back to the computer. I don't know when I'll get around to editing this or getting it up. I'm hoping sometime this weekend I can get this computer up and working again, but we'll see. For now, that's it. I'm a very tired, confused radio mechanic, and see you soon, I hope. Talk to you. Bye.